we'll look at how you can use a range of ways to determine how sounds fall off over distance. So far, we've looked at using the fall-off distance to control sound's attenuation over distance as we move away or towards an audio object. But now we can control how it falls off over that distance by choosing from different attenuation functions or curves. We'll also look at how you can define your own fall-off curves for specific use cases, and how you might combine different sound elements with different curves in order to reveal the different layers of audio detail over distance. In the demonstration project, we're going to browse to find the lake here and press F to focus on it. Now, in this instance, our attenuation is defined within the ambient sound actor itself, since we have override attenuation checked here. So we've looked at this before, using an attenuation shape, in this case a sphere, to define the inner radius when the sound is at its maximum volume, and then this falls off to essentially a volume of 0 at this fall off distance here. Now what we haven't looked at yet is this attenuation function. So if we use this drop down menu, you can see we've got a choice of different curves in terms of how the sound is going to drop off over that distance. The lake is set to the linear curve. This is the default function. When using this function, the volume will attenuate linearly, and so the changes are constant as the listener moves towards or away from the source. This function is good for crossfading between large background area loop type sounds. So back in our level, play the game. I'm going to solo that particular sound using the console command audio solo sound wave. The loop lake. And we can hear more clearly how the lake sound just begins at the edge of the village and then fades in a linear way over that distance until we're inside that inner radius. We'll now jump to a second sound inside the village here. We've got this fire. Now for this sound, it suited the sound to have a logarithmic function. With a logarithmic function, changes in volume are much greater at these closer distances, and then it drops off much more slowly as we get further away. It's good for spot sounds that need good 3D positioning. So we can hear this in the level if we use audio, solo, sound, wave, fire. It ramps up quite quickly as we're close to it, and then extends more quietly over a longer distance. If we want to exaggerate that even more, we might use an inverse function here that just tightens up that curve towards the object even more than the logarithmic function does. In the level, we can see an example of that for the waterfall sound. Now, when we're right up against it here, as we might expect, that sounds a very broad bandwidth sound. It's going to dominate and mask everything around it, but we still want to hear it from quite far away, perhaps even over at this field, without those sounds dominating everything else. So let's have a listen. I'm going to use the audio solo sound cue this time because the waterfall's made up of a couple of sounds. And we start to hear that waterfall quite gently over this side of the field. And as we get closer, it's going to quite quickly ramp up. So that gives us the sound of the inverse sound function. The log reverse has almost the opposite effect, so there's not much change in the volume of the sound until we get right at the outer range of it. There's not really a particularly appropriate sound in the level to demonstrate this one, so you can experiment with it yourself. What we have used is this final curve, which is the natural sound. So it attempts to mimic a more naturalistic fall off in behavior. So this is shown in green. It's very similar to the logarithmic fall off shown in blue. It's kind of a middle ground between the logarithmic and the inverse functions. So in the level, We can see this in the skylark. So this skylark is just on the edge of the meadow here. And I wanted it to be heard over the whole meadow, but to have quite a natural sound as you approach it. I've just muted these cricket sounds here temporarily so that we can hear it a bit more clearly in context. So the skylark is that melodic bird you can hear. And we should be hearing that natural fall off over distance. The attenuation functions you choose to use, be they linear, logarithmic, inverse, log reverse, or natural sounds, are really dependent on the characteristics of the sounds themselves. So this is going to take quite a lot of experimentation to choose the right fall-off curve or attenuation function for your particular sound. The other thing we can do to add some nice detail to sounds is to think about how sometimes different elements of a sound might be revealed over distance. So bookmark 7 takes us to cave 2, and in these side caves here, we've got these sort of glowing magical effects, which you can see there if I press G for the game mode. Now, this sound here, you can see actually appears to have several attenuation curves within it. The final sound is actually produced by a combination of these three elements. We have a low sound, we hear when we're quite far away, and then a mid sound blends into that. And when we're right up close to the center of the orb, we hear these elements. Each layer has its own attenuation settings and its own attenuation function, so linear, natural sound, and logarithmic. We can see here a graphical representation of that. So as we come in, we hear the low layer first with a linear curve up to 400, which is the inner radius. Then we hear the mid layer with a natural sound curve. And then finally, the higher layer elements come in with a logarithmic curve between 750 and again up to 400, that inner radius. So let's have a listen. There's the low layer. Just starting to hear the mid layer. And there's higher elements as we're right on top of it. Now you may find that none of these existing attenuation functions actually give you the kind of sound that you want. So you might want to actually create a custom one. That's what we've done here for this magical effect in the center of the cave. So this sound is the torus loop, and it uses actually an attenuation asset called torus. And if we open that up, we can see that we've used a custom attenuation curve, not one of these preset approaches, but a one specific for our use. This is because the magical sound effect is quite unique. What we wanted was for the sound to get louder from the fall off distance up into its inner radius here, shown in this yellow sphere. But then when we're actually inside that magical torus shape, we wanted the sound to drop off and be silent. So if you look at our custom attenuation curve, what we've got is this one value here represents the volume of the sound at the fall off distance. So at 1, which is the fall off distance of 2876, the sound will be silent. Then it will gradually get louder until this point here, which is about where the graphical effect starts to come in. And then in the inner radius, which is represented here by 0, the sound is actually going to be silent. So when you're making a custom attenuation curve, what you need to remember is 0 represents the inner radius and the 1 represents where the fall off distance is. So we can hear that in this cave, and I'll solo that effect. So we start to hear it here. So inside our fall off distance, it's going to take quite a linear approach to volume up until this point. Here, it's going to quickly descend, and actually within that inner radius it's going to be silent. So for that particular object, we wanted that unique effect, and so we created our own custom attenuation function. Different curves or functions over distance will suit different sounds, and you may have some specific cases where you want to define your own curve like this. What's particularly useful for some circumstances is to define different attenuations for different components of the sound, as we saw with the orbs in the side of the cave. This can reveal different elements of the sound over distance. It's particularly useful for weapon sounds, for example, where at a large distance you might just hear the boom element, but up close you might hear the click of the mechanical firing mechanisms. Finding and choosing the right attenuation function for your sounds is going to depend on their unique characteristics, so there's going to be quite a lot of trial and error involved.